Hi ladies, I just want to make a little tutorial video about adding up vectors in the forces unit. It'll be pretty much the same as what you've seen in the past, but I'll just go over it real quick just for those who might need extra help solving vectors. So this is the package that you received. We're going to be doing this one together. It's number 15, and I think it's the hardest one, so I'll just go over through that one and hopefully you can do the easier ones on your own. So here's how I'm going to do it. First things first, I'm going to draw a picture of it. So here we have my little box. Alright. I have 5 newtons going up. Alright. 2 newtons going down. 3 newtons going to the side. And then 7 newtons going in this direction at a 30-degree angle. Alright. The first thing I want you to do is to draw a Cartesian graph. Alright, and we know that this is the x direction and this is the y direction, or the x-axis and the y-axis. And I want you to draw all the vectors starting from the center of this Cartesian graph. So going upwards, we have one that's 5 newtons. We have one that's sideways, that goes 3 newtons. One that goes off at an angle to the side, that's 7 newtons, and that's at 30 degrees. And we have one that goes downwards on 2 newtons. Alright, so what we're going to need to do is break those all down into x and y components. Alright, so before we do that, I want to number off the vectors to v1, v2, v3, v4. You can number them however way you want. I chose to number them like this, and it'll just make adding the vectors a bit easier. Alright, so the next thing I want you to do is to draw a table here. Where we're going to add up all the vectors together. Alright, so we have the x vectors and we have the y vectors. Alright, we have vector 1, vector 2, vector 3, vector 4. Alright, and we're going to draw the x and y, we're going to write down the x and y components for each vector in these boxes. So for vector 1, if we look here, there is no x component at all. So it's 0 newtons. Right? It's all y component. So I'm going to write 5 newtons here. For vector 2, it's all x component. So it's 3 newtons to the side, right? And there's no y component. Vector 3 is one that goes on an angle, right? So it's got an x component and a y component. Alright, so using SOHCAHTOA, you can figure out that the x component is the magnitude, so that's 7. Sine, is it sine? Opposite over adjacent. So it's actually cos. (30 degrees). And the y vector is 7 sine 30 degrees. Alright, and vector 4 only has a y component, and that's 2 newtons, and the x component has 0. The next thing I want you to do is look at the direction of each of the units. Alright, so everything above the x-axis is considered positive y. Everything below the x-axis is considered negative y. So vector 1 is going in the positive y direction, so it's going to be a positive symbol. In vector 2, you're going in the positive x direction, and you have no y direction. In vector 3, you have a positive x direction, but a negative y direction. See how it goes underneath that x-axis? And then for vector 4, you're going again underneath the x-axis, so you're negative. Alright, this will make adding up the vectors much easier. So now we have to add up the totals. Alright. So we're going to do 3 newtons. So I'm going to do that on my calculator. 3, well, let's clear this up. 3 plus 7 cosine of 30 plus 0. Right? So that's 9.06 newtons. Alright, now let's do the same thing for the y. So it's 5 minus 7 sine 30 minus 2. And that's minus 0.5 newtons. Alright, so if we draw a new resulting vector, we're going 9.06 newtons off to the side, because it's a positive value, and 0.5 newtons downwards because it's a negative value. So 0.5 newtons downwards. Alright, so F net has this magnitude. And to find that magnitude, we just have to use Pythagoras. So 9.06 squared plus 0.5 squared, all that square roots gives us 9.07 newtons. Alright, so the magnitude of this vector is 9.07 newtons. Okay, now all we need to find is the angle, this small angle here. So we can see that because this is a big x direction and a small y direction, we're going to have a really small angle. So if we get a big angle, we know we did something wrong. To do that, you just have to do the inverse tan of opposite over adjacent. Alright, so remember it's SOHCAHTOA, opposite over adjacent. So opposite is 0.5 over 9.06. And that's equal to 3.16 degrees. Alright, that makes sense. A small angle, 3.16 degrees. So our answer, F net, is going to be equal to 9.07 newtons east, 3.16 degrees south. That's your final answer. That's the resulting vector. I hope that makes sense. If you have any questions, don't hesitate to ask me. I hope this video helped you.